Section 7.2 talks about integration of logarithmic and exponential functions. Well, derivative of a natural log of x is 1 over x. Done deal. If I take a derivative of an absolute value, derivative of natural log of absolute value of x, absolute value of x is either x if x is bigger than 0 or negative x if x is less than 0. If I take a derivative of natural log of x, that's 1 over x. If I take a derivative of natural log of negative x, that's 1 over negative x times the derivative of negative x by the chain rule, which gives you 1 over x. Which means, if I take a derivative of natural log of absolute value of x, I'll get 1 over x regardless. Now, antiderivative is going back. What do you integrate to get 1 over x? Well, that must be the natural log of absolute value of x. Something you need to remember. Now, the derivative of an exponential function is the exponential function, so the antiderivative is the same. It's really simple. A note that's going to save you some work. Do remember that when you take a derivative of e to the kx, if this k happens to be a constant, that will be the exponential times that k by the chain rule. Antiderivative is undoing a derivative. If I was to ask, what did you take a derivative to get e to the kx, it would be wise for you to say, oops, look at that, almost messed it up, e to the kx, and since when you take a derivative, you multiply by k, when you take an antiderivative, it should make sense to divide by k. Instead of using a u sub every time, that saves you a lot of work. So for example, if I'm looking at the integral of e to the 3x dx, I could say let u equal the power, because that's the tradition. Du is 3 dx, so this is the integral. This would be my u, and my du will be du with a 1/3, right? And that would be 1/3 e to the u. That would be 1/3 e, and what was u? U was 3x, right there, plus c. So instead of doing all of these steps, it would be much simpler for us to really get this out of the way and say, look, the integral of e to the 3x dx. When I take a derivative, I get e to the 3x, so that's e to the 3x. But if I take a derivative, I would multiply by the 3. Since I'm undoing that, instead of multiplying, I divide by the 3 and make use of that note. That's going to save us some work. It would be wise to do. So I start looking at problem number A, or example A. I'm glancing at this and I notice, well, it's not as obvious yet. I'm going to let u equal 3 minus 2x. The denominator of a fraction, if you remember, that was the deal. Du is negative 2 dx. Well, this is my integral. That's my u. And dx is really du with a negative 1/2. So that is negative 1/2 natural log of absolute value of u plus c, right? And if we recall what was u, it was 3 minus 2x, and that's how it's done. Fairly simple. Just use the u sub correctly. Well, let's look at the next problem. Again, I'm going to let u equal, in the tradition, the denominator of a fraction, 1 plus 2x cubed. Du will be, bring the power down, 6x squared dx. So this is my integral, and I notice that u is right there. And x squared dx, well, that's simply du over 6. So this is 1 over 6 natural log of absolute value of u plus c. substitute back what u equal, and pretty much you're done. And u was, if you look up there, it is 1 plus 2x cubed. And that's pretty much it. Here the same deal, but here I have a definite integral. I should change the limits on the integral. I let u equal x squared plus 5. du is 2x dx. So this becomes my integral, and I have few changes to make. First change, the denominator is u. The second change, x times dx, I noticed that that's a du over 2. So there's dx and there's x. Now, the limits on the integral. If x equals 0, u equal a 5. And if x equals a 3, what is that? 9 plus 5 is 14. This is 1/2 natural log of absolute value of u. And you notice here, I don't have to go back to x. And that's going to be 1/2 natural log of 14 minus natural log of 5. This is more than an enough answer for a test. There's nothing wrong with this as an answer. The back of the book might say that's 1/2 natural log, and they combine those. You don't have to do that. They might even take that and make it as a power. Again, for the homework, you want to match the back of the book, but for our test, this is sufficient. D, well, if I really don't want to use the u sub, that's e to the 4x. When I take a derivative, I multiply by 4. When I take an antiderivative, I divide by 4. That simple. If I look at e, I let u equal traditionally the power negative t squared. du is negative 2t dt. By the way, you could let u equal t squared only if you wish. Both ways you'll get the same answer. There's my u, so I have e and u is right there. And t dt is my du. That would be du with a negative 1/2. So that is negative 1/2 e to the u plus c. And what's u? u is negative t squared. There it is. Here, it's habitual to let u equal the denominator. So du would be negative sine of x dx. So if I glance at this integral, I notice I let the denominator be u. And x dx, I can get that to be a negative du. And this is nothing more than natural log of absolute value of u plus c, and that would be 3 plus cosine of x. The back of the book might take that and make it a power. They do that sometimes, and you'll get natural log of absolute value of 1 over 1 plus 3. Of course, you don't have to do that, but it is doable if one wishes. I need to shift that up just a bit. There it is. I have 3 more examples to go. So, traditionally, I let u equal the inside of the power function. Let u equal e to the x minus 5. du is e to the x dx. So, my u is right there. And e to the x dx is du. That would be u to the 11 divided by 11 plus c. And if I recall what my u equals, it's right there. It is e to the x minus 5. And there it is. Here, I would let you equal the tradition, the denominator. Okay. I'll get there, don't worry. So du is negative twice cosecant squared of x dx. So there is, okay, it didn't register. There is my u. My du is right there. That would be, oh, and by the way, pi over 4. Cotangent is 1, right? 1 plus 2 is 3. And pi over 2. Cotangent is 0 to 1. So that would be negative 1/2 times, and this is nothing more than natural log of absolute value of u evaluated from 3 to 1. So that would be negative 1/2 times natural log of 1 minus natural log of 3. And we are aware, again, on a test, I'll accept this as an answer. Natural log of 1 is 0. So the back of the book will have 1/2 natural log of 3 or natural log of square root of 3. But this is a fine answer, and you could leave the answer like that. That's not a problem. We come to another tricky part. If I take a derivative of 3 to the x, that's 3 to the x times natural log of 3. Do you remember that? If I take an antiderivative, that is 3 to the x, instead of multiplying by natural log of 3, to undo multiplication, you would divide plus c, and that's the easiest way to remember this, I think. You could use a u sub, but this is much simpler. And that would be it for this section.